Welcome today to our Technomatics virtual user group. We are discussing modeling index tables using transporters and trucks. So thanks for joining. Our speaker for today, as usual, is Mr. Steffen Bangsow. He is a freelance simulation expert, and he has been doing this for many years, completing hundreds of projects and training sessions. We love having him here with us because he's one of our leading contributors to our community. So that's it for my introduction, and Steffen, feel free to steal the screen.
Hello again. Today, I want to create with you index tables, and there's many description of this. If I try to translate it, indexing, rotary tables, rotary indexing units, palette changer. Mostly you have a round table, and around this round tables you have several workstations or walking positions. You have at least one position for feeding this unit, and one or several walking positions. If the rotating, if the index table it's running only in one direction, you cannot use poses. Poses you need to go back, and then you it's difficult if the table rotates back, and in reality it isn't this case. And so I want to create this table using track and one transporter. Okay, let's start. What I want to do is the most simple form of the index table. It should be a palette changer for loading a machine parallel to its processing. And so you have a table here which is rotating by 180 degrees. And one worker is feeding the machine while the machine is running. And so in the first step, I want to create such a table. And first I need a track. And this track should be completely round. And so I added the 3D appearance of this track. I click here on segments. I don't need the length here. You can set here a curve angle, and this should be minus 360 degrees. And the radius should be 0.75 meters. Okay. And then you get a round track. I change the width to 0.1, and then I have the track for my table. Next, I need the table itself, and for creating this, I duplicate a transporter and name it index table. And open this in 3D. Okay, I don't need this transporter. I also don't need the andon light, so I switch off the states. I need a round form here. I create a cylinder, radius 0.75 meters, height 0.01. Wait, okay. And then one trick is the position of this table needs to be here in this way, not at the center. I need this with the yeah. Next, I want to have two texts, one of the positions of the I have two positions on this table. One and two. Okay, now I have a table, and I need to change the MU animation. First, I need to look here into the settings of the transporter. Load B need to be store, and capacity is 2, x2 and y1. And this is important if I create the animation structure. I have two places X, and so I need to change the MU animation. I switch off the animation area, and then I need to set animation paths, two of them. First, should be where the 1 is. And then I need a second one for the second place. And this should be where the 2 is. So I need two anchor points. If you have an index table with more than 2 places, you need to create more of them. Okay, so I created the index table. And now I can short test if this is fitting. I just so if you get such an effect, then your 3D measurements doesn't fit here, but we can get the with tools calculate dimensions from 3D. We get the right. Okay, so now I make one trick here in the index table. I change in 3D scale automatically. I switch it off, and then I change the length to a very small value, so the positioning is much better. Okay, and if I now put it here, then it looks quite nice, and I change in 3D the set position to 2. And now I have my palette changer in the machine. I guess only one. In the same way, you can create a index table with more than 2 places. You only need to change the number of animation structures on this plate. we need to make here, we need to close this this track. We need one connector from the end to the start, so that the index table can turn. And if I now start the simulation, okay, I need. Then it turns. If I switch this to backwards, then you can also change the direction. Okay. Now we need some controls for this table. I programmed the controls in the track here as user-defined attributes. First, I need for the control, I need attribute is turning, so that that we can wait until the turning is finished, and this should be Boolean and initial value is false. I need a connection to the machine. I can do this as a user-defined attribute of type object. And in this case, this is station. And I need init method. To create the index table. On this track. Okay, these are only for preparing. Now, if I start the simulation, I have my table and the table is turning. So I need to stop this turning, and for control this turntable, I want to have two sensors, which is calling the same sensor control. And so I can make another user-defined attribute, sensor control. As a method. And here I need two sensors. The first sensor is on position 0. And the other sensor is on the half at 180 degrees. And my track is 4.71 and so on. So I need a sensor at the position 2.356. And I also call sensor control at this position. And in this sensor control, I want to program the logic of my turntable. And the first step is I need to stop this turntable. Let's stop true, and I want to stopped. You cannot observe stopped directly, and so I need a user-defined attribute for observe the turning movement of my table, and so I use the user-defined attribute is turning to show the turning is finished. So now I have several cases. And the first case is the turntable is empty and the machine is also empty, and so the worker needs to place the first part on this table, and then we need to turn. And so I need to wait until the table is occupied. And then I turn. And to show it outside, I set my is turning attribute to true. Okay, this is the first case. Worker comes, place the first part on this table, and we turn, and then we have second part. The second case, turning is over. It's hit the next sensor, and then I have the case. We have one part on the table, and the machine is empty. In this case, I just place the part on the machine. And then I wait for finishing the part. And there's several ways. At the end, the machine will be blocked if I don't move the part from the machine, and the machine is has finished the processing, and so I can wait until the machine is blocked. And then we need to decide, okay, on which position we have to load this part. And if we hit the sensor at the 0th position, it's the position number 1. And if we hit the sensor number 2, then it's the position 2, we have to load. And so we have two different cases for loading the table. If we can use the sensor ID here, if this is 1, then we need to load the part on position number 2, and we can use PE to address one special place on the transporter. As a sensor ID is 2, then we need to move the part on the position 1, on the first place on the table. And then we need to wait for the worker. The worker needs to load the next part on this table, and then the table should have 2 parts on it. And so we can wait until the number of parts number is 2, and then we start the movement. And then we have an else block. Else means, okay, it's not empty, it's not 1 part. We have 2 parts on this table. And then we need to unload the right position. And so we have a similar case here. If we have 2 parts, then the machine needs to be empty. Sensor ID is 1. Then okay, we need to unload, in this case, place 2, 1. We wait until the machine is finished. And then we unload the machine again to the same place. Else, quite the same. If it's the position number 2, then we need to unload the first place and move the part again back to the first place. And at the end, we need to wait until the table is completely filled. And we start the movement. Okay, this is only 2 positions. If you have 3, 4, 5, 6 or more positions on this index table, then you have a lot more cases you need to program here. And you can have robots, you can have machines, and maybe you have different loading and unloading positions. So this can become very complex. Okay, this would be one simple program for 2 places. And now we need to load this machine. And so we need to complete my scenario here. I have a source, I have a train. I need a worker for loading all the stuff, and broker. And then I need workplaces, one here with a transport importer. Here also a transport importer, and here I don't need an importer here. First here, this transport importer, we need to set a destination, and the destination should be a station. And we want to load in parallel during the processing of the machine. And so we need to deactivate wait for free target. Otherwise, it would not work. And I need a small control in the source, because we need to restrict the transports towards the machine. And I want to trigger the transport if the turntable is completely empty. And so I create an exit control for the source. And this is not nice, but I want also to have the worker completely empty. Okay. Let's have a try. And now the worker it's loading directly the station, because this workplace is connected to the station. And so we need to change the basic behavior of the worker. And this we can do since 2504 using the unload control of the workplace. And so I want to use this. As it creates a lot of code we don't need. So I delete all this. For the index table, I want to have a variable here as object. One condition we need to observe here is turning. This should be false, and then I can move the part. Oh, I forgot one. I need a table index here. One moment. Need the sensor control. Oh yeah, I missed one line. I only know here in this method the sensor ID, but I need to, for loading from the worker side, I also need to know the sensor ID, and so I need to have here another attribute, for instance, table index as integer, and after each turning, I need to set this table index to the sensor ID. Okay, and this I need here for loading. I can load the place with the table index, because here's my sensor number 1 and there's the sensor number 2, and so I can use this table index to select the right place for loading. Okay, let's try again. It's turning, it's not right. Okay, it's turning is on the track and not on the. Okay, now it's working. Okay. Next, I want to call the worker for unload the index table after finishing the processing, and there we have a problem. If we call the worker directly with the transport importer from the station, the worker will load the part from the station and not from the index table. So we need to make here some little trick. I use for this a second station. I make it a little smaller. And this station has also a workplace with active transport importer. You can place both of these workplaces over each other, and so you only see one. And then, okay, then I set here the destination to train in this transport importer. And here in this station, I deactivate the transport importer to avoid the direct loading of this part from the station. And I need here an exit control, and in this exit control, I just create a part here on station 2, and this will call the worker and activate the transport importer. So I take a exit control. I don't move the part here. The turntable will move the part. And I just take a part here. So now if the worker comes, he will load the part here, and so we need to avoid this direct loading of this part. Instead, he should load one part from the table. And this again, we can use, for this again, we can use the unload control of the workplace. This is the load control now. And so we can test this here. Okay, this is too narrow. So without any changes and more programming, he just load the part from this dummy station, and but it should first he should wait until the turning is over, and then he should load the right part from the index table. And so we need to change the basic standard, the basic behavior of the worker. And this again we can do with the load control. A lot of code we don't need. So first we need to wait. We wait until the turning is finished, and then we need to address the part. It's very important. Too many Ds. And the part is track.cont.p. The right position is table index on the worker side. And one, this is the part.cont. Destination is drain. And then we load this part onto the worker. The worker is here add dot move. And we delayed the part on the station 2. Okay. One change. I don't want to have the worker all the time here, and so I deactivate worker stays here after completing the job. And I set the time a little bit higher to 1 minute. And now it should work. Turns. Now the machine is start working. Now in parallel to the working, to the processing on the machine, we can load another part here. Now this is empty completely, and then I can take the next part to the table. Then I can do something else with my worker. Okay, this is quite complex from the steps, but you can parameterize this behavior very, very well and very easily. And so you can, if you have a lot of such machines, you can create your own library elements for the turntable track and the index table and the connection between all the elements. And so you only need to develop it once, and then you can place it several times in your simulation. And the really fun is if you have such index tables with 5, 6, 10, there are really big such rotary index units in reality, and then it becomes really complex. And yeah, that's it for this webinar. Okay. Any questions?
Hello, thank you for the nice presentation. I actually have a question regarding the modeling of workers. I recently stumbled upon a problem that I have lifted the working place from 0 to 20 centimeters height, actually. And this really caused problems because Plant Simulation gave me an error that I could not really decipher. In the end, it was the problem that the workplace was lifted to that level. Is there any way without a stairs or anything else that the workers can also change the level where they do work actually, or does it always have to track?
No, you can use the work path. If you use the work path and edit the anchor points of the work path so that the work path can reach this height, then the worker will go on the work path to the workplace. Otherwise, it needs to be really at the same set position.
All right, okay, because that was the point. I used the free floating workers without any paths between. So in that case, I have to somehow connect the different levels with each other.
Yes, you can use the footpath, and you edit the it's like the track in 3D. You have segments, and then you can set the delta set in the segments table. I share. Okay, if you have a footpath, or I need to stop here first. I need the footpath here. I lift this a little bit to 0.5. And then you need a footpath. Take this a little bit. So. And here you can edit the 3D properties, appearance, that you have segments. And then you can have a delta set of 0.5. Okay. And then you need a connection between this footpath and this workplace. And then have a look. And then he goes up to this workplace, and then it works. Stairs
it's like
is another way.
Then. All right. Okay. Thank you very much.
Yeah. Okay.
maybe another quick add-on question.
Yeah.
I also did some automatic model generation with workplaces. So I created different layouts for a job shop production actually, and in there was the issue that sometimes with specific configurations of the layouts that I have imported, the workplaces have just overlap with a buffer or a workstation or anything else. And at this point, the simulation, of course, stops and tells me, oh, the workers cannot reach the working position. Is there any option to detect this blocked workplace somehow in advance and maybe to change the position of the workplace? Or like an overlap or something? I have not seen any properties of the workplace or the stations or anything else.
Okay. You can press the O button and then you can see the obstacles. And but then you need to check the corner points. And if you are inside of this obstacle, I guess if you want to do this with SimTalk, it becomes very difficult.
Yeah, okay, because that was actually it was part of a large set of experiments. We have created the layouts, ran a simulation, and then evaluated them against each other. And yes,
but
the experiment manager did not really throw an error. It's just running through. So it took some time to find it out. But yeah, of course, there were some layouts that were not, let's say, feasible.
Yeah, but if you have really such a in this case, you can just switch off all the obstacles for the workers here in graphics, and then obstacle for worker none. And this you can change in the class library, and then you don't have these problems if it doesn't count, if it not influence something here, and so you can avoid this. And then it can be directly inside of this object, and it works still. And this is
okay. Thank you very much.
So it works now without any obstacles.
Yeah. I see. Okay. And maybe a last question, if it's all right, or if I'm just
yeah.
Okay. The experiment manager also to change the number of workers. There's not really an easy way to do this, I think, without external variable and a method that changes the creation table of the workers in the worker pool. Is this still the best practice to use a method called the creation table of the worker pool, alter the number of workers, and then write it back to the worker pool as a method to do this automatically?
No. It's the way you need to do this.
Okay.
Yeah, you cannot directly. Sometimes you have direct access to the table, but if you have set and get methods for reading and setting the tables, you need to do this in this way.
Yeah. Sometimes I also had the issue that I changed the number of workers, let's say by a global variable. Then the init method activated the writing process of the new worker number after a reset, but it was not really written. But after the second reset and the re-init, it did.
No. The worker will be created before the init method is called. So we need to change this earlier. And there's a configuration method inside the experiment manager. Okay.
Yeah, I've seen that. I've used it and it works actually. But if I do a normal run and change with a variable, with a global variable, then it still is ahead of the init of the event controller, I think. Is it like this?
No. The event controller first calls the it's in advanced settings here in the in the event controller in the experiment manager, and then if you make a configuration method, then it will be called before the init method is called.
Okay.
You can also use. You can also use. You can also use, for instance, an observer control for a global variable for value, and the experiment manager will change the value, and then it starts the simulation, and the experiment manager calls the init method. So it becomes also before the init. But you cannot do this inside the init method. It's too late.
Oh, okay. But in the init method of the event controller, am I still earlier than the worker pool is creating?
No, in the configuration control of the experiment manager.
No, I'm talking about the event controller. So if I do not run an experiment, but I do manually change a global variable, let's say change 6 to 8 workers, and then my method would be activated to write into the worker pool, then I would also better use an observer method of this variable to immediately set it, or could I also be earlier with the init method of the event controller? So
the event controller, the init of the event controller is the first, what's happened in the experiment, and so it's still delayed.
Okay.
The worker pool, the worker will be created before the init method is called.
Oh,
and so
okay, interesting.
Yeah.
Yeah, so with the observer on a variable, this would be feasible as well. Okay.
Yes, because the experiment manager will change the value of the variable if this is one of your inputs.
All right. Okay. So I wasn't really sure about the behavior of the worker pool, but if it's earlier than anything else except for the experiment manager, then I understood. Thank you.
Okay.
This is the link to the forum. So this is where the recording will be posted on Friday. You can see the website, image of it on the screen. That GIF is also animated. It's showing that we recommend that you follow the topic, and then you can click on the envelope icon there to select every post, which just means that you will receive a system email whenever we post new content. And the only thing we post there is links to register for one of these sessions, recordings for one of these sessions, and occasionally people post questions, typically about one of these sessions. So it's very narrow, which should be of interest to anybody who's doing plant simulation. And then, as you can see, those are our next 2 meetings. Again, these are all clickable links. So what's new in Plant Sim? Steffen will walk us through that in the next session 2 weeks from now. And then we will also have a session on creating HTML reports in plant simulation. So definitely click through if you want to join for either of those topics. And then if you're new with us, our team at Siemens Accelerator Academy offers comprehensive training, and we just like to make people aware of that. So there are a few links here. You can see live training, learning membership opportunities. There's also a plant simulation associate certificate that's there. So all of that is available to you if you are interested in it. And then this one's really fun, another opportunity to get in person if you are near or want to travel to Germany. Then in October, there will be a session at the Infinity Hotel. You can use the QR code to register for this. You can also click the link here on the screen. And they're expecting about 300 people and 30 sessions. So that should be a good time. It is absolutely free to participate. So putting that there. And of course, Steffen will be presenting also at this, if you're wondering. You all see the link to Steffen's profile in the community there. You also have the link to the forums if you didn't already have those and haven't bookmarked them. So that is there on the screen for where the recording will be. If there's no more questions, we will see you all in the forums.
Bye.
So, yeah. Thanks, Steffen. Bye, everyone.